Hey, welcome to Algebra. Today we're going to learn how to solve systems of linear inequalities by using desmos. Okay, so first thing we need to know is we need to know the line rules. Okay, so it's a solid line if it is less than or greater than or equal to or less than or equal to. And we're going to put a dashed line if it's greater than or less than. So this kind of goes back to, remember, like when we did it on a number line, greater than or equal to or less than or equal to, it had a filled in circle, right? Had a filled in circle, and then it had an arrow going one way or another, right? So this is kind of like the same thing. So a solid line means it's greater than or equal to or less than or equal to. Where, like, remember, greater than or less than had an open circle. So to show that open circle while we're graphing it on like on an actual coordinate plane or an actual graph, right? To show that it's an open circle, we use dash lines. So like when you make the line, literally instead of making a solid line, you just make dashes going up like that. Okay? Something else you might need to know is we have to shade below our line or above our line. So if we're shading below our line, it's going to be less than or equal to. So like this one, less than, it would have a dash line, and then we would shade everything below it, like that. Less than or equal to would have a solid line, and then we would shade everything below it, just like color it in below it. Right? If we were going to shade above, that means it's going to be greater than or equal to. And greater than would have a dotted line, and then it would have shade above it, right? Or greater than or equal to would have a solid line, and you would shade above it, the color in above it. Okay? So that's important to know. All right, solid line has the line underneath. Dash lines, no line underneath, right? If we're shading below, that means it's a less than or equal to, and that kind of makes sense, right? If you're shading below something, you're shading underneath of it, that means it's going to be smaller than it, right? Where if you're shading above a line, that means it's going to be bigger than it, so that means it has to be greater than or equal to. Okay? Okay, so how do we do this? Well, we're going to graph them in desmos. Our solutions are in the shaded region. So solid lines are part of our solution. So if I get a dot that's on a solid line, that is part of our solutions. If you get a dot that's not on a solid line, it's on a dash line, then it's not part of our solution. Okay? All right, so let's do some of these together on desmos and see how we do. All right, so let's do this first one here. Let's open up desmos. I got to delete what I had in here before. All right, and I see it says y is less than or equal to 3/5 x. So I'm gonna hit y. Less than or equal to is right here, and it says 3/5, right? So 3 divided by 5, and then it says x. So I'm gonna type x. Then it says minus 5. All right, so I can see my graph here. It's at -5. So let's go ahead and graph it and copy it over. So my y-intercept's at -5, which is here. And then it says my slope is 3/5, right? So that means I go up 3, 1, 2, 3 over 5. 1, 2, 3, 4, 5. All right, and just like on desmos, this has a solid line because it has a less than or equal to sign. So it's a solid line. And you see on desmos how they shaded it below, right? They shaded it below down here. So we're going to shade in anything down here below. This is all I'm going to shade it in. That's a great color job, isn't it? Okay, so what we're going to do is we're going to see which solutions are part of my graph here. So 2, -2, if I could do that. So 2, -2, it's right here. That's not in my shaded part, right? So that is not an answer. 2, -2 is not an answer. It's not in my shaded region. All right, so let's try 6, -4. If I go over to 6 and go down to -4, that would be here. That's in our shaded region, right? And if we're just doing it on desmos, I could see that here too. 6 is here. -4 would be like here, right? So it's in our shaded region. So that's part of our answer. So that is a solution. All right, so let's see 0, -5. 0, -5 is right there. That's on our solid line. So if it's on a solid line, that is part of our solution. So out of the 3 choices they gave us, 2 of these work. This one and this one work. So this one's in the shaded region, and this one's on a solid line. Okay? All right, so let's try the next one. 3x minus 2y is less than 10. Let's see what that looks like. 3x minus 2y is less than 10. All right, ooh, nice gray dark color. I like it. All right, so I see this one has a dash line, and that makes sense because there's no line underneath here, right? So let's graph it. It says my y-intercept's at -5. So I'm putting down -5. And then it says my slope, it looks like it is, what's another good point here? So this looks like a good point here, right here. So let's see here. It's up 1, 2, 3 over 1, 2. So up 3 over 2. So up 3, 1, 2, 3 over 2. That'd be my next dot. Up 3, 1, 2, 3 over 2. That's my next dot. Up 3, 1, 2, 3 over 2. That would be here. Okay? And this has a dash line, right? Dash, 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 right? So I matched my desmos there. Okay? And it has all this shaded above it. So anything in this shaded region over here, and my pink that I'm doing here, would be an answer. So let's see. 2, 3. If I go over to 2 and up to 3, that would be right here. So that's part of my answer. That works. 6, 3. Let's go. 6 and 1, 2, 3. That's not in my shaded region, right? So that doesn't work. All right, 2, negative 2. So let's see here. 2, negative 2 is right here. That's on my line. All right, but this is a dashed line, right? So that's a dashed line. So that does not work. If it's on the line, it only works if it's on the solid line. So this would not be a solution. Okay, so your solutions are always in these shaded regions, or if it's on a solid line. Okay, so sometimes they're going to give you a system of inequalities, and that means they're going to give you 2 inequalities, and you have to figure out what the solutions are. Okay, so first we're going to graph them in desmos, and then we're going to identify where the shading regions overlap. Remember, a solid line is part of our solution, so if it's on a solid line, it counts as part of our solution, and if it's on a dashed line, it is not part of our solution. All right, so if I want to do this first one, I would plug it in desmos. I can clear this out. I have y is less than 2x minus 3. That says there in like that reddish orange color. And then we have 2x plus y is greater than 3. Greater than 3. And that's in the blue spot there, right? So my answer for when there's a systems, which means there's 2 inequalities, it's where the 2 overlap. So you can see here's just the blue, right? Here's just my red. We want to see where the 2 overlap. So the 2 overlap in this area right here, right? All this area over here. So any point in this area where they're both overlapping would be a solution. Right? If it's just in the blue section, it's not a solution. It has to work for both. If it's just in the red section, it's not a solution. It has to work for both. It has to be where they both overlap. All right? Well, that is how we solve systems and desmos. If you ever have any questions, please ask a teacher, and I'll catch you next time. Bye!